The world is changing. We are living through the most extreme forces of nature, from mountains splitting apart to the deepest storms. Imagine standing on a mountain peak. Now imagine that very ground beneath your feet is quite literally splitting apart. This is the real, terrifying situation unfolding right now in the Alps, where the iconic Hochfjell is showing clear and undeniable signs that its time may be running out. It is a slow-motion catastrophe, but the final break is coming. At the summit, a massive, wide-open fissure has fractured the stone. This crack is more than 100 feet long, but the scale of the vertical drop is even more shocking. Some parts of this fracture plunge straight down, disappearing into the darkness for up to a staggering 60 meters. Recent measurements confirm that this fissure is expanding with every season, growing faster than ever before. The volume of rock poised to collapse is almost impossible to comprehend. Experts estimate the massive, unstable section of the mountain is ready to shear off at up to 260,000 cubic meters. To help grasp the immense scale of this potential disaster, picture this. That is the same total volume of rock equal to approximately 260 entire single-family houses. Some researchers looking at the entire potential fracture zone believe the unstable volume could be even larger, closer to 400,000 to 600,000 cubic meters. A rockfall of this extreme historic size would not only severely reshape the valleys at the mountain's base, but would unleash shock waves that would ripple far across the mountain landscape. The Hochvogel is not merely just another ridge in the Alps. Rising nearly 8,500 feet, 2,592 meters above sea level, it stands alone as a striking, solitary landmark positioned directly on the border between Bavaria in Germany and Tyrol in Austria. For centuries, it has been an essential reference point for surveyors, explorers, and the local shepherds. Geologically, this entire mountain is primarily composed of a material called Main dolomite, a Triassic sedimentary rock. While dolomite is a naturally sturdy rock, it is also brittle, and it is here that its fundamental weakness is exposed. This instability is a problem with deep roots. A massive rockfall event was recorded back in 1935, and smaller slides have occurred repeatedly in the decades since, including in 2005, 2007, and 2016. Historical reports show the presence of a cleft on the summit dating all the way back to the 19th century. What is truly accelerating this threat and forcing this ancient mountain to fail today is the direct and profound impact of a changing climate. This connects to one of the most critical elements deep inside the rock: permafrost melting. In the high mountain regions of the Alps, the ice that is perpetually frozen within the mountain acts like a powerful stabilizing glue, physically holding the fractured rock masses together. As global temperatures rise and the mountain warms, this internal ice melts away. This melting process instantly reduces the rock's internal friction, causing the once solid foundation to transform into a weak, water-saturated one. This permafrost degradation has become a primary, essential variable in understanding why this mountain is failing in our lifetime. The frequency of extreme weather events in the Alps, specifically more intense rainfall and hotter summers, has already doubled in recent decades, adding immense stress to the entire stone structure. Even lightning strikes are now being scientifically studied for how their electric energy may weaken the internal rock layers, leaving them more vulnerable when saturated by rain. To fight against this unseen, rapidly destructive geological process, researchers have deployed the AlpSense Bench, one of the most advanced mountain monitoring systems in existence. Think of the entire system as generating a constant, updating 3D digital twin of the Hochvogel. The sensors track even the smallest shift, capable of detecting movements as fine as a tenth of a millimeter. The fissure itself is consistently growing by up to 2.5 millimeters every month. The installation and maintenance of this system have been a dramatic struggle against the elements. The extreme alpine conditions led to system damage and data loss, particularly due to repeated destructive lightning strikes that hit the summit. This required the scientists to change their entire system design to protect the vital data. Beyond the visual measurements, the researchers use seismometers to literally eavesdrop on the alpine peak as it breaks. They are listening to the mountain's resonance vibration. The pitch of this vibration changes like a violin string as stress builds up in the rock mass. Researchers have repeatedly observed a characteristic sawtooth pattern in the mountain's frequency. The pitch rises with stress over several days and then suddenly drops after a small rock-cracking event. If these specific cycles become shorter and more frequent, it is the clear scientific signal that a massive rock breakup is rapidly approaching. The mountain is now sending very clear, measurable signals of its final instability. Water is the immediate, direct trigger that causes the mountain movement to speed up. Researchers have calculated the specific time lags that dictate danger. Snowmelt causes rock displacement with a measurable time lag of 4 to 9 days. Even more immediately, heavy rainfall can cause the mountain movement to accelerate within a short window of just 1 to 16 hours. We have seen how fast this process can become irreversible. This scenario mirrors a case in the Swiss village of Blatten, where a minor movement rate shift from a centimeter per day to a centimeter per hour triggered a catastrophic full collapse. The sophisticated Hochvogel sensors are now watching intently for that exact deadly acceleration. If the worst happens, the enormous rock mass is expected to rush into Austria's Hornbach Valley and the Hinterstein Valley in Germany. While this region does not contain a dense city, it is a well-used area filled with hiking trails, remote alpine huts, and pastures. For anyone caught there, the outcome would be devastating. Authorities have reinforced early warning systems and believe that with just 2 days' notice, they could successfully evacuate people and save lives. However, the collapse may not be a single quick event. Experts believe the disintegration of the mountain will likely occur in multiple phases, stretching out over months or even years. This means the mountain could remain unstable for decades, forcing long-term trail closures and significantly impacting local tourism. There is also the critical concern about the secondary mud and debris flows that will inevitably follow the main rockfall, pushing the destruction even farther into the adjacent valleys. This long-term, slow-burn uncertainty is already having a profound psychological effect on both residents and regular visitors. The mountain, which for centuries symbolized permanence and eternal strength, now stands as a symbol of fragility and represents a silent, ongoing threat. Trails that once felt serene now feel uncertain, even threatening. The Hochvogel isn't just a mountain, it is a powerful warning. It is a crucial living laboratory where climate change, geology, and time are violently colliding. It shows us all that even landscapes we once thought permanent are fragile, and that the comforting phrase, solid as a rock, loses its entire meaning when the rock itself is clearly, visibly breaking apart.